Children, in this one more question related to coordinate geometry, where you have to find out the solution of linear simultaneous equation graphically, you have to draw a graph in which you are going to plot the given two equations. Now always remember that whenever a linear equation is represented on a graph, it is expressed on a graph, it always forms a straight line. So in this question, as it is given, solve graphically 2x plus y is equal to 6, and another equation that is given x minus 2y is equal to minus 2. Now this question means that you have to use the graph instead of cross multiplication method or elimination method or substitution method, which you were doing it earlier in the chapter of simultaneous linear equation. So the first step for solving this question is that you are going to make y as the subject over here. Again, as you can see over here, I have transposed this 2x on the other side, and now the equation has become y is equal to 6 minus 2x. Now I have made a table over here in which I have taken few values of x. Now children, remember that you can take any such values, whatever you feel like, but don't take quite big values, because in that situation what will happen, you won't be able to adjust it on the graph, you won't be able to adjust the coordinates that are going to form. So it will be better that you take smaller values and take such values so that you can get your answer, you can get the value of the y as a whole number. So for solving, for finding out the coordinates of this particular linear equation, I have taken the values of x as 1, 2 or 3. You can take other values also, that is your choice. Now in this you are going to find, when I have substituted the value of x as 1 in this given equation, which I have just changed into making y as a subject, this has become y is equal to 6 minus 2 into 1. In place of x I have substituted 1. So this will give us 6 minus 2 is equal to 4. That means the value of y is coming out to be 4 when x is given as 1. In the same manner, when I have substituted the other value of x as 2 in this given equation, now the equation has become y is equal to 6 minus 2 into 2. That is 6 minus 4 is equal to 2. That means on substituting the value 2 in place of x, I have got the value of y as 2. And in the same manner, for the third value of x, that is 3, on substituting in this given equation, y is equal to 6 minus 2 into 3. That will give us 6 minus 6 is equal to 0. So that means when I have substituted the value of x as 3, I have got the value as 0. So these values I have substituted in the table. When the value of x was 1, I have got 4. When the value of x was 2, I have got 2. When the value of x was 3, I have got 0. So now the coordinates are formed as 1, 4, 2, 2 and 3, 0. And as you can see, I have written the coordinates over here. 1, 4, 2, 2, 3, 0. In the same manner, you are going to find I have done it for the second equation also. The second equation is x minus 2y is equal to minus 2. In this, what I have done, I have shifted 2y on the other side and minus 2 on this side. So I have got the equation as x plus 2 is equal to 2y. Now in order to find out the value of y, or in order to make y as a subject, I have cross multiplied this 2, which was the coefficient of y. And now I've got the equation as y is equal to x plus 2 upon 2. So I've made y the subject over here. Again, as I told you that I'm going to make a table over here in which I'm going to substitute certain values of x, for which I'll be getting some values of y in order to form the coordinate. Now it is your choice, you can take any values of x, but remember that take smaller values and take such values so that you can get the value of y in the form of a whole number. So for this particular equation that I've formed and made y as the subject, I've taken the value of x as 2, 0 and minus 2. Now see what will happen when I'm going to substitute the values. When I've substituted the value of x as 2 in this equation, I've got y is equal to 2 plus 2 upon 2, that is 4 upon 2. On cancelling, I've got 2. That means for x is equal to 2, I've got the value for y as 2. When I've substituted the value of x as 0 in this equation, then y is equal to 0 plus 2 upon 2. I've got again 2 upon 2, that is 1. That means on substituting the value of x as 0, I've got the value of y as 1. Similarly, for the last value, that is for x is equal to minus 2, y is equal to minus 2 plus 2 upon 2. Minus 2 and plus 2 will give you 0. 0.2 is 0. That means for the value of x as minus 2, you have got the value of y as 0. So in this way, you can form again 3 coordinates. I've written the values for x is equal to 2, y is 2. For x is equal to 0, y is 1. For x is equal to minus 2, the y is 0. So in this way, I've got the coordinates as 2, 2, 0, 1, minus 2, 0. And you can see I've written the coordinates over here. That is, coordinates are 2, 2, 0, 1, minus 2, 0. Now what I'm going to do, I am going to plot the coordinates for the first linear equation as well as for the second linear equation, and wherever they are going to meet, from that we can get the solution. Children, as you can see that on a graph paper, I have drawn both the axis, that is x-axis, this is the horizontal line, and the y-axis, that is a vertical line. And now I've plotted the point. The first point that I've plotted for the first line is 1, 4. So as you can see, this is the vertical line passing from 1, and this is the horizontal line passing from 4. They are meeting over here. Okay, so I've made a cross over here so that it looks more visible. Similarly, I've plotted the second point, which was 2, 2. So the vertical line through the x-axis for 2 is going over here, and the horizontal line through the y-axis passing through 2 is coming over here. So this is the second point. And similarly, the third point, that was 3, 0. So that I've plotted over here on the x-axis. Similarly, I've plotted 3 other points for the second line, in which the first point was 2, 2 that I've plotted over here. That is the common point for the first line as well as for the second line. The second point was 0, 1, that is on the y-axis, and the third point was minus 2, 0 that I've plotted on the x-axis. So as you can see, children, that when I have joined these 3 points, I've got this straight line for the first equation, and when I've joined these 3 points, I've got again a straight line for the given equation, and both the straight lines are meeting at this particular point 2, 2. So if you are going to draw a perpendicular from this point on the x-axis as well as on the y-axis, you are going to find that this is your required solution. In this way, remember that point of intersection is coming out to be 2, 2. That means the value of x will be 2 and the value of y will be also 2. In this way, for the given 2 linear equations, I have figured out the answer not by using cross multiplication, substitution or elimination method, but by taking the help of a graph. And remember, on a graph paper, you are never going to use a pen. Though I have shown it just to make it more visible to you, you are going to do all the graph work with a pencil only.